welcoming you to the Netherlands. You
Thank
will
you.
be giving your speech in English, of course.
I'm afraid so.
No, don't be afraid. I think it will be no problem. It's all yours, the stage.
Okay.
Good luck.
27 minutes starts now.
Yes.
Okay, wonderful. Okay, well, thank you very much for being here to listen to me. My name is Tim Ashton. I'm marketing manager for a group called Advantech within Carrier that has the objective of working closely and collaborating with our customers to achieve their goals and their needs, whatever they may be. Recently, we've worked on the Sistine Chapel, and we've worked with data centers in Sweden, developing cooling for the data center whilst rejecting heat into district heating networks to create smart urban environments. I'd like to share with you today a little bit of a project that we've done in the area of driving towards net zero energy buildings. You know, today we're facing unprecedented change, as you know. There are new risks and new opportunities all around us, whether it's in our security, urbanization, regulations, sustainability and technology. But all of these things, and that's what we're here today to talk about, affect us in one particular area, which is buildings. You know, we spend about 70% of our lives in buildings, and so it's the way these buildings evolve in the future, become more sustainable, more smart. That's going to impact all of us in terms of comfort, energy, and carbon emissions. As I said, these buildings, we have opportunities increasingly today to make these buildings smarter. So what do I mean by that? I mean to deliver better comfort, have better security for ourselves in terms of fire, in terms of personal security, improve the efficiency of these buildings in terms of the services they deliver and the environment that we work and breathe within. And in doing all of that, reduce the amount of energy that's being consumed. Sustainable buildings and smart buildings, we need to integrate the technologies so that they work together to achieve those goals. Are there benefits in doing this? Well, clearly there are. So many years now, data is being collected that shows that these buildings are greener, they demand higher rent on average, they use less energy, they're easier to rent, and we improve the indoor air quality within those buildings. By that, we achieve more productive employees and a better experience within those buildings. We are able already to optimize the plant control in terms of cooling and heating, and we're able to improve the comfort and use in those buildings of people transportation, reducing the energy that's being used and improving the travel time and experience within that building. But let's take a little bit of a look about the energy used by a building today. On the left-hand side, we know that buildings globally use around 40%, depending on the location, of the energy in the world. On the right-hand side, you see the different elements and energy use in that building. Now, the HVAC, the heating, ventilation, and air conditioning systems, use typically 40%. And what you can see there is other areas such as lighting, sanitary hot water services, mobility, IT, and other things. Now, what if we could improve the way that those systems integrate and function together? What if we integrated some of the technology we have today, such as, for example, we recover heat from the air conditioning system and we use it to supplement the heating water, the sanitary hot water. We can reduce the amount of energy being used in that building by recycling and recovering. But to do that, we need to work in a system way. We need to work in a holistic way, and we need to work together. I make this point because this system feeling requires a change, and now is the time to change. We need to move away from a step-by-step process where each actor plays within a different phase of that building design, development, and construction. We need to be able to share and together innovative ideas and processes and modify the way we design that building to achieve our results. So we need to work towards an integrated, holistic design approach from start to finish. And we need to significantly change the way we work today as an industry to achieve those targets. From an HVAC point of view, let me just give you a small example of what I mean by that. We in Carrier, with our Advantech team, we have tools that allow us to dynamically simulate buildings and systems. They give us the opportunity to model and develop new products and new equipment before they're even built. So we can see the impact of them before installing those within the system. But what does that mean? It means we need to share with the designer and the architect information on the building, its envelope, the way it's going to be used, the way it's going to be designed. And it's a reiterative process. We need to go through that with the design team together to get to the result and target that we need. The focus here is dynamic system analysis and optimization together as a team. By doing this, we can come up with the right proposal for the right project in the right location. So with that as a background, what I'd like to present very briefly for you today is some of what's happened in a particular project that we did in Paris. It's called La Belloise. It's about a 7,000 square meter building. It was a refurbishment project, and the customer concerned wished to achieve a zero net energy building. By going through the traditional conventional design process, basically what happened is everybody told him that it wasn't possible, not in this refurbishment project. So he came to us and he engaged with the Advantech team, and we believe we could do something to get him a long way towards that target and achieve what he really wanted to do. So as you see here, typical buildings in this area are using 250 kilowatt hours per square meter per year. Using a traditional conventional process, he could get to around 100, but he really wanted to target 0. Okay? He had some other challenges I'll come back to later. So he targeted 4 times reduction in energy. He wanted to eliminate mechanical plant rooms, and he wanted to improve upon the speed of construction and not have any extra costs in terms of installation. So the team worked together, and what I wanted to share with you here was just a few ideas before getting into the details. We worked together from a construction point of view, building envelope, and we worked together from a climatic point of view, the location of that building. And there's some interesting findings and thoughts here. I mean, typically the first approach to reducing energy is to insulate the building. And that's really where the architect and the designer was going in the first place. If you like, even over-insulating the building. Because in fact, the reality is when you insulate the building too much, the internal gains, the heat that's generated can't escape. Because they can't escape in a more traditional way, of course we have to provide more cooling for a given situation. But at the same time, that heat can't escape, and therefore the heating loads improve. The real message here is about optimizing the design to achieve the right balance. Now, at the same time, as we insulate that building and we make it more hermetic, we have still to address the needs of ventilation, indoor air quality. So the mechanical ventilation systems, or the systems in place, still need to provide sufficient air for that building's use and purpose. So this is actually positive because it gives us an opportunity to improve and to find ways to optimize the energy balance between the cooling and the heating side. Having done this analysis as a team for this particular project, what you see here is an analysis of the outdoor air temperature conditions and the location versus the cooling and the heating set points that you see in the red and the blue bar on the screen. And what you see at the bottom is the analysis on the cooling and heating side. The data you see here is over 8,760 hours. What the team then did is analyze different ways to balance out, optimize that data. So of course you see some of the ideas that are quite well known. Heat recovery and free cooling through the ventilation system, combined with smarter zone ventilation management. This was one of the areas that the team focused on. The other area it focused on was how to recover, redistribute, and reuse the energy throughout the hydronic system in the building. bearing in mind that was the system the customer wanted, a hydronic-based system. So we did a lot of work on dynamic analysis on those aspects of the design. This is just two areas of focus that we then looked at, because having done the design, we need to move towards designing the system itself. So what you see at the top is those heat load analysis that I mentioned in the slide before. And what I'm showing you here is there are periods of the year where we can use free cooling and make significant energy reductions through the ventilation system. At the same time, there are periods in the year where we can recover heat from the building before the air is exhausted from the building, and again, reduce the amount of extra energy we need to input into that system. The other area we looked at, of course, is the period of the season which we will call mid-seasons. This is where we have both heating and cooling needs in that particular building. What we looked at and what we wanted to optimize was the transfer of the energy within the building from zone to zone. The idea here is to not create any extra energy than is already existing within the system. Though there may be, of course, times when we need some extra cooling or we need some extra heating. What you see on the right-hand side is the concept that we wanted to develop that I will show you in the next few slides. What we wanted to do was look for a heat pump type solution. Heat pumps have the advantage of not only be able to produce heat, but also to be able to produce cooling. And, as I've mentioned, they have the ability to transfer heat throughout the building. Hence the word, a heat pump. We can move that heat around. And nowadays we can do so very efficiently. So with that as a background, we were now in a situation where we knew how to improve the energy efficiency in terms of system design. We knew how the areas to improve upon: sanitary hot water use, free cooling, airside heat recovery, and we wanted to better manage the occupancy ventilation. Now, I just remind you, the customer had some constraints for us. He wanted a chill beam type of system, a hydronic system. He wanted a floor-by-floor approach to that building. He wanted to eliminate traditional plant rooms in order to gain more rental space. And, as I mentioned, he still wanted a modular comfort approach to that system. And of course, finally, as all of the actors in the building design chain, we wanted to be able to provide a fast-track, modular, efficient installation. So on the far right of this slide, you see that we had a few challenges. Some of the products exist today, be it water-cooled chillers, be it heat pumps, air handling units, and terminal chill beam systems. But we were missing a few of the components we needed for that system architecture. Before showing you the system, this is an overview of the system. What you see is the zonal HVAC on number 1. This is where we're dealing with the comfort conditions in the zone. And of course, that subsection of the system is linked to both the airside system from a ventilation point of view, and it's also linked to the water side system in terms of providing the extra cooling or the extra heating required by those beams. So let's just take a little look at the two breakdowns of that system. So here, the system proposed was still based upon a traditional chilled beam approach, but modified. What we wanted to do considerably differently is have a variable air volume approach on the ventilation air. In order to do that, and in order to reduce energy, we wanted to eliminate the traditional use of variable dampers to adjust the air volume based on occupancy. By doing this, we estimated we could save about 30% of the fan energy that's normally lost at those dampers, and in the process reduce the energy needed by the air handling unit in distributing the ventilation air. So we were looking for a smart ventilation module. Optimize the ventilation, manage it based on occupancy with CO2, and also optimize the free cooling possibilities, deliver more air than necessary when outdoor conditions permitted it. On the far right, we have the traditional chill beam, which we had access to, so there was no issue in terms of providing that part of the system. And the air handling unit itself, as I mentioned, has a heat recovery wheel, and so that's available to us as well. Now on the water loop, there's a little bit more difference here. What you see is a thermal energy loop through the building, broken down into the components of the air conditioning section, dealing with the different zones. Then we have the sanitary hot water section, and then we have the toilet flush system. And in this system here, we introduced energy storage tanks on a floor-by-floor basis. Again, we had the larger air-cooled or reversible heat pump product available, but what we were looking for was a small, smart air conditioning unit, a heat pump unit that could do cooling and heating when needed, but a unit that could move the energy around the building on a modular zonal basis. So we looked at these particular products in terms of our system architecture. What I'm showing you here very briefly are the two new products that were developed for this system. At this stage, though, I would remind you, they are still simulation concepts. So the first one is a small variable air volume fan-based unit that plugs into the main distribution ductwork. It adapts and monitors the air delivered based on comfort requirements, CO2-based management. It helps reduce the main air handling unit supply fan static, and it facilitates the free cooling when it's possible. At the bottom, what you see is a brand new water-to-water reversible heat pump, modular approach, delivering up to 2.5 kilowatts, up to 3 kilowatts in heating, with a variable speed compressor. So a very fine possibility of control, with integrated water pump and controls. Now, we had a system concept. We knew the parts that we needed. And this was the time, once again, as part of the design team, to work with the architect and the building designer to see how to fit it into that building and how to eliminate the plant rooms. So what you see here are the first hand sketches, where we worked together and laid out, you can see at the top on the right, the small air treatment modules and the heat pumps installed in a ceiling space above a toilet area was the original design. And you also see an air handling unit in the ceiling voids inside of the building itself. And this was developed on a floor-by-floor basis. To validate that concept, we then moved towards a BIM modeling approach and worked with the architect and the designer to draw up working documents and drawings to validate whether it was possible. And we also used this phase to decide the dimensions and the modular nature of the products that had to fit into that space. So on the left-hand side, you can see that this heat pump is only 175 millimeters wide, 590 deep, and some 350 high. But we weren't finished. Now, I'd said it was a reiteration approach, so now we had to go back into the building process with the design team. We remodeled the building with its envelope and its design as we had decided with the architect. We redefined the internal loads, schedules, all of the data required, and we rebuilt the models in the simulation tools that we had, putting into it the proposed system that we have now designed and come up with. The result of that modeling you see here. So basically, we were able to look at the energy used by the compressors, the fans, the pumps, and the air handling unit system on a yearly basis. And we were able to deduce that we could, in fact, meet the targets we'd set out to achieve as a design team together. One interesting thing happened. We discovered, as we had reduced the energy by the different components in that system so significantly, that the energy being consumed by the controls had become quite a significant part of the system energy. So what we did is we designed a concept called Sentinel Colony approach, where basically controllers are grouped into colonies, and one or more of the controllers within that colony acts as a sentinel. So when the building is in an unoccupied state, or people are not in the zones concerned, the main controllers can all go into a sleep mode and consume no energy. And the sentinel controller will survey on what is going on in the area. If there's a need to wake up a controller, it can then wake up the controllers in order to manage the cooling and the heating. In this way, we were able to reduce the estimated annual energy of the controls significantly again. Well, we had to now validate this in practice, right? Because that was just simulation and that's just theory. So indeed we did. It so happened that in the Carrier factory based in Mont-Laval in France, we had a refurbishment going on of an area where our quality department works. So we took this opportunity to fit this area out. It's basically 170 square meters roughly. There are 4 offices, there's a conference room, and there's some meeting rooms that are available. We took the opportunity to install a complete system with an installer to validate the concept, to validate if it was easy, the time it would take, the cost, and the results were in line with what we expected. And of course, we were able to run thermal comfort and energy monitoring tests on the complete system. We did this over a period from May to November, and in fact, we then kept going during 2 years. So we were able to prove in practice that we were able to deliver the energy savings that we had designed for as a team. So now, this is not a particularly easy photo to see, but if we go back to the real job, La Belloise, we installed this system in this building. You can see on the left-hand side a couple of screenshots of the variable air volume ventilation terminals installed in the ceilings. In the middle section, you can see the water-to-water heat pump modules racked, plug-and-play modular approach. And on the right-hand side, you can see the chill beam terminals being installed. What was the result? Well, the result was, and it's now been installed and running for over a year, that we were able to deliver a building, and I say a building, not the HVAC, the total building only uses 25 kilowatt hours per square meters per year. And this is a refurbished building, okay? So we were able to deliver the results the customer wanted with the comfort expected, and we were only able to do this, and I insist upon this, it's important, by working together from start to finish as a team in a holistic way, by sharing and interacting together to design the required system. Now, we talked about buildings at the beginning, intelligent, smart buildings and optimizing the building. Just share with you a couple of things. If we go beyond the HVAC system and we start to integrate other components of that system, we have our sister company Otis that has worked now for 15 years at a product level, improving the energy usage of those products through belt drives, flat belts, by regenerating drives, which regenerates the electricity back into the grid, standby modules, and even storage of energy in batteries now during the motion of those elevators. And they've been able to reduce the energy of those systems by over 50% over 15 years. But now we said smart and integrated. So the next stage of that process, and I come back to that from a system point of view, is smart use and management of those systems. So here you see a software, Compass Plus, that is a destination management software that analyzes and the use of the lifts and elevators in that building every 5 minutes during the day. And using that data, it changes and manages which lifts to send to which floors in order to reduce energy. And in this case, we're achieving another 27% savings at the people transportation level. Smart management. Well, my final slide really is just to say to you, we've achieved fantastic things with an HVAC system. We can do more with people transportation. Well, why not move to the next level? If we can bring together all of the technologies in the building and work together in the right way, in a holistic, innovative way, we can move building design probably to zero, and why not even a generator of energy for the future. So, with that slide, thank you very much for listening. If you have more specific questions, we have a stand, and I'd be delighted to speak with you there.
Thank you so much, Tim Ashton. Vragen, questions, remarks? Think about it, because right now he's still here. I was just wondering about one thing. of this sublime, holistic idea, which is putting into function so many different ways and working. How are you marketing it?
I'm here today.
Yeah, because that's the thing.
Yes.
I mean, it's so important, but to bring all these different people together, working as a team, that's already quite something. But then also to put it in market and being able to use this in other projects, that would be key.
It's a real challenge, and thank you for the question. It's a challenge, and what we've been trying to do is, it's something that's growing. I think you would all accept that we are having to change the way we work as an industry. And in order to achieve that, we have to start small and build on our successes. So basically, I am traveling a lot and presenting and sharing with customers. I visit customers and get their feedback and input. We are doing marketing. I invite you to look at the Sistine Chapel on the YouTube if you want to see another example of how Advantech have helped improve the system that's there. And we're doing as much as we can to promote, working with my colleagues, and looking forward to your questions.
Yes. Well, if there are any questions, I would love to hear them right now. Otherwise, I would love to give you the opportunity to have your stand and being able to answer questions over there. Yes?
Okay.
All right. Well, thank you so much for this wonderful story. I wish you the best of luck.
Thank you very much,
And
too.
I'm sure you will have that. Ladies and gentlemen, Tim Ashton.
Thank you.